All right, good morning or good afternoon, whichever it is for you. We are on lesson number 4. So again, I'm just going in order. I did skip coordinating graphs because I put that at the end. These lessons you do need to do in order because they build on each other. And so we are on lesson number 4. So I'm going to follow the same procedure that we've done. We're going to add some information to our notes. Then we're going to do our guided practice together like we always do. And then we're going to stop and give you some time to do some independent practice. And at that point, you can open up a new video and check your work. And as you finish all the practice problems and then the homework, if you send me a quick picture, I will send you a picture of my completed ones so that you can check your work. All right, here we go. So we are on estimating weight, and we're going to flip over to our guided notes that we've been taking either on a piece of paper or in a journal. And we said that our standard that we've been building on is that we know the unit that we're going to be measuring in, we know how to convert units, and we know what we're measuring. Are we measuring length? This could also be width. Length, width, and then we're moving on today to measuring weight. So I'm going to write weight. And you know from science that weight is the pull, a measure of the pull of gravity that the Earth exerts on a force. But it's also, on Earth, it's indistinguishable from the term mass. Because when we're on the Earth, we have the same weight and the same mass. And remember from science, mass is a measure of the amount of matter. Mass matters. Now, on Earth, these are equivalent or the same. But if we were to go to Jupiter, our mass would be bigger because our weight would change. Sorry, our mass would stay the same because we're the same person. We didn't become a fluffy cloud or we didn't become a heavy elephant, but we would feel heavier. We would feel so heavy on Jupiter because the gravity is greater that we would be squashed like a pancake and I would look like I gained 1,000,000 pounds. Or if we went to the moon, which has a smaller mass, our mass would stay the same, but the gravitational pull of the moon would be lighter because the object, the moon, is smaller. And so it would make our weight change, and our weight would be lighter on the moon. And that's why when you see the astronauts walking on the moon, they appear to kind of float up, and because their weight is lighter. So in space, the mass would stay the same, the weight would change, but on Earth, these two are the same. In math, they're going to refer to the unit that you're measuring as weight, but if you're looking at science, they're going to refer to it as mass. Same thing when you're talking on the Earth. And so we're going to measure. So if we look at our notes for today, no, Simone, we're not going outside. We're going to look at the two main measurements that we use for U.S. customary, which is ounces, and we abbreviate that OZ. So I'm going to write that one down because whenever you have something that is a little bit different, you always write the abbreviation down as well. And then we have pounds. And pounds are LBS. And I think we've talked about it before. The word pound in French is libre. And libre, if you look at it, I think it's libre, something like that. But it is LBS, and that's how they got the abbreviation, even though it doesn't look, it should be like PDS, but it's not, it's LBS. And you will have to know these abbreviations. They will go back and forth and provide them, and you have to know that this is measuring in pounds. And so you're going to think ounces and pounds when you think weight. Just think about if you went to the doctor and they measured you on that scale. And so we're going to use a scale. And then there's going to be a couple other tools they're going to use to measure. So specifically, if you're measuring in science, they're going to use a really cool tool called a pan balance. And these are 4th grade skills, so I know you've probably measured with the pan balance before. I'm sorry I couldn't send the pan balance home, but the scale, so we either stand on the scale or there's scales that hang like in the grocery store, and then the pan balance. And so we're going to flip over and look at our textbook. So we are on page 819. 819. And if you look down at the bottom, this is a pan balance. And just think of a teeter-totter. So activate your prior knowledge, think what you already know. If you're on a seesaw or a teeter-totter, this little thing right here, I'll give you some fancy science words, this is called a fulcrum. And then of course gravity is going to pull it down, right? And it's going to move the balance. And so think what you know. If you have the same size person on the teeter-totter, you just stay still. But if you have Miss Dunnigan over here and you have Ava over here, it's going to go down. So the heavier weight or mass pulls it down. And if you had, and this is very similar to what we were talking about with our force and mass and motion. If you had Ava on this side and Miss Dunnigan on this side, then Miss Dunnigan's going to go down on this side, and that would be greater on this side. So wherever the greater amount is, that side goes down. If the masses are equivalent or equal, they stay the same. All right, so we're going to just look through. This is going to be a little bit harder to do because we are don't have our pan balance. So I'm going to go to my grocery store and I'm going to find us some things that we can use to think about ounces. And this will help you a little bit. All right. So I just pulled some things out of my fridge real quick. Here's a can of peaches, and it is 15 ounces. 15 ounces. So you can kind of hold that in your hand and get a sense of how heavy that is. 15 ounces. Now the typical, when you think of an ounce, the measurement they always think of is a deck of cards. So if you hold a deck of cards in your hand, a deck of cards weighs approximately 8 ounces. Now I'm going to look at butter. So butter is a half a cup, and every cup is worth 8 ounces. So if you hold a stick of butter in your hand, that's going to be about 4 ounces. So this will give you some kind of measurements to hold on to and think about when you think about measurement. So if we look at an eraser, we're just going to measure. So it says the weight of an object is measured by how heavy it is. Heavy. We're going to measure it in ounces, OZ, or in pounds, LBS. And we're going to estimate or give our best guess. So think about an eraser. If this is 8, how much would one of those big pink erasers weigh? And you probably said something like maybe 1 ounce. So think deck of cards, 8 ounces, and then you know your own measurement in pounds. So when you're thinking of pounds, you're going to think about that. All right. A glue bottle. A glue bottle. About the same as a deck of cards. Unfortunately, we can't do the actual because we don't have a pan balance or scale. A math book. We could measure this in ounces, but probably it's going to be closer to, what do you think? Probably more like a pound. All right, now pencil. So if those big pink erasers are 1 ounce, how much do you think a pencil would be? Maybe 1/5 of an ounce. Definitely some sort of a fraction or decimal, not a whole ounce. All right, so if you were to measure, when you have these pan balances, you have a little cup and you put one object in one side, and then you have these weights, and they say little measurements on one side, and you have little ones and big ones, and you would dump these into your bucket and see if it makes your bucket is go down or go down on this side, and you're going to keep adding weights until your bucket would be equal. There are other scales that have a little counter right down here, and you're going to put your pieces into this side until you find where it lists on your number. So, and typically at this point, no one goes out and actually has a pan balance anymore. You're going to have a scale. So you're going to put an object, and if the grocery store scales you might have seen look something like this, and then you put your objects in here and you see where the scale goes to. There's also a really cool balance, which is what you measure at the doctor's office. And so you probably remember standing on a scale, and then it has this little slider at the top, and you slide a big weight, a medium weight, and a tiny weight until you can find where it balances, and then that shows you the amount up there. Or they're electronic now. So this is called the triple beam balance. I would love if we could find some of those at our school. When we get back, we'll definitely measure those with those, and we'll definitely measure with a pan balance. But for now, I just wanted to kind of give you a little bit of background knowledge. So all the balances and scales today are electronic. You just put the object in, and then it tells you the amount. All right. So we're going to do a couple. So our standard today is estimating and measuring with weight. We're only going to do a couple of the problems. Place a 1 pound weight of the side of the balance. So I'm just going to draw a picture. And place a 1 ounce weight. So think in your head, which is bigger or which is smaller? Which is bigger and which is smaller, pounds or ounces? Big and small. So how, if I put only 1 ounce on my teeter-totter, what is going to happen to my 1 pound? Is it going to go up or down if 1 ounce is on the other side? Well, this would be bigger. So if I only had 1 ounce, that would be like